Hi, so in this project we'll be going through Cl versus CLF3. Here I already drew up CLF3, which is chlorine trifluoride. This is what this Lewis structure would look like. The Cl would be right in the middle, bonding six of its electrons to each of the Fs. Each F will be bonding 2 electrons, all satisfying their octet rule. After going through of it, we'll have 4 leftover electrons, which will simply be put on the bottom. All equaling 28 electrons, making sure that they're all symmetrical. For formal charge calculations, here I'll move out of the frame a bit. Sorry. The formal charge calculations, we have Cl, which has 7 valence electrons, minus 4 that are non-bonding, the ones that we put at the bottom, minus the 6 that bonded already, divided by 2. Then equaling 0. For fluorine, since they're all symmetrical, doing 1 will equate to us doing all 3 of them. 7 valence electrons minus 6 that are not bonding, which are around, minus the 2 that are already bonding with Cl, divided by 2 equaling 0. Okay, so for CLF's turn, which is chlorine monofluoride, the Lewis structure looks exactly like this. We have 2 pairing electrons in the middle, and then we have 6 non-bonding electrons all around, equaling 14 electrons if you count them over. Both actually satisfying their own octet rule. So for the formal charge calculation, which I have to move a bit out of the frame, chlorine has 7 valence electrons minus 6 that are not bonding, which are the ones around, minus 2 divided by 2, which is pretty much bonding electrons divided by 2, equaling 0. Fluorine, exact same thing, 7 valence electrons minus 6 non-bonding, the ones around, minus 2 that are bonding, divided by 2, equaling 0.
Good morning. So for my part of the video, I'll be doing resonance structure and stability of CLF and CLF3. So I'll be defining resonance structure. I put here 3 main points. So a resonance structure, it's simply just a different way to represent the Lewis structure of that molecule. But one really important thing to point out that I put here is that whenever you do the resonance structure of that molecule, you can only move the electrons. You can't move the atom. The actual structure for that molecule is a hybrid of all the resonance structures that you do. So since the nitrogen doesn't have a octet of electrons, I can get one of the pairs of electrons and make a double bond. So I can actually create a double bond with any of the oxygens. It doesn't matter which one. So all of these structures are equivalent. All of them are correct, but the actual structure is a hybrid of all of these. So now that we've covered that, our molecule, CLF and CLF3, it has an octet of electrons here and an octet of electrons here, and same thing with the CLF3. We can't use a resonance structure for our molecule, so it doesn't apply. Okay, so here I've made the Lewis structure for CLF3, and we can check the stability of this structure. So generally, the structure with the most charges that are closest to 0 is the most stable structure. In our Lewis structure for CLF3, the formal charge is 0, so we know that this is the most stable structure. There's actually this equation that you can do to find the stability, and it's a formal charge equals the valence electrons minus the non-bonding valence electrons minus the bonding valence electrons divided by 2. So to test this out, Cl, we have 7 valence electrons minus 4 are non-bonding, which is these 4 here, minus 6 divided by 2, which is the ones that are these 6 that are bonded, and we divided by 2. So 7 minus 4 minus 3 gives it 0. So we have a charge of 0. And then for the F, they're all the same, so we can just do 1. We have 7 valence electrons from the periodic table, and we have 6 non-bonding valence electrons for our F. and 2 bonding electrons here. 7 minus 6 minus 1 gives us 0. So the formal charge for the F is also 0.
For more part of the video project, I will be covering rule violations and molecular geometry and polarity for CLF3 and CLF. I'm going to flip the camera so you have a little better understanding of what I'm trying to say. For rule violations for CLF3, since there are 3 covalent bonds, they will be all shared, and the 6 electrons will break the octet rule because Cl will have more than 8 electrons shared, which will ultimately break the octet rule, which allows only 8 electrons to be shared. However, CLF does not violate the octet rule because each electron in the valence shell has only 8 electrons, so it is not expanding, it is not below the quota. For electron geometry, CLF3 has the T-shaped with the 175 bond angle, while CLF has the square pyramidal shape. And for polarity, they both have an asymmetrical charge distribution around the central atom, so that makes both of them polar.
Okay, so the physical properties of CIF, it has a density of 1.62 grams per ml, it has a melting point of negative 155.6 Celsius, and it has a boiling point of 100 degrees Celsius, 0.1. And then the chemical properties are that it has a colorless gas and it destroys glass, and it also has a slightly yellow color if it's a liquid. In the CIF3, the density is gonna be 1.77 grams per centimeters cubed. Boiling point is gonna be 11.75 Celsius. Melting point is gonna be negative 76.34 Celsius. And then some properties is that it has a pale yellow color, it's soluble in water, and its molar mass is going to be 92.448 grams per mole.